Good morning. Today we are going to solve a problem DC shunt generator. Take down this problem. A 4-pole shunt generator with lab connected armature as a armature resistance and the field resistance of 0.2 ohms and 50 ohms respectively. It supplies power to 100 lamps each of 60 watts 200 volts. Solve for total armature current and generator EMF. So we need to calculate what is the total armature current, that is IA, and as well as generated EMF EG. So here the load is given as 100 lamps of each of 60 watts and 200 volts is given. So first given terms, so 4 poles is 4 pole and armature resistance RA is equal to 0.2 ohms. So field resistance RHS, that is given as 50 ohms. So number of lamps is given as 100 lamps. So power per lamp is 60 watts. So terminal voltage also given, that is 200 volts. So now the total power supplied by the generator is so 100 lamps into 60 lamps, power per lamp is 60 watts. So 100 into 60 is 6000 watts. So this is the total power supplied by the generator, because the load means the power supply also by the generator also will be the same. So that is the shunt DC shunt generator. So now we are drawing the just diagram, okay, equivalent diagram of the shunt generator. So sorry, this is the generator G. So you need to mention this as G generator. So from this it is supplying to a lamp. So shunt resistance. So here notations we need to change as G. So from this diagram, so shunt resistance is given as 50 ohms, and here the lamp here it is 6000 watts. Okay, so lamp load is 6000 watts. Terminal voltage okay, that is 200 volts. So the generator, that is the power is generated. So the power from the generator. So here the armature current is IA. Okay, so IA is divided into two. That is shunt current and as well as the load current. Okay, so that is the power generated from the generator. So now from this we need to find out the what is the load current. Load current IL is equal to this P by V, that is by Ohm's law. So P is 6000 watts divided by terminal voltage is 200. So the load current we got it as 30 amperes. So this is the load current. The IL is equal to 30 amperes. Next, we need to find out what is the shunt field current. So shunt field current I shunt is equal to V divided by RSH. Okay, so shunt resistance is given. So terminal voltage 200 divided by 50. Then only you can find out the armature current. So I shunt is equal to 4 amperes. Now armature current IA is equal to, because IA is divided into IL plus I shunt. So IL plus I shunt. So IL what we calculate is 30 amperes. I shunt is 4 amperes. So armature current IA is equal to 34 amperes. So generated EMF, because the problem what they is total armature current that we calculate generated EMF. So generated EMF EG we need to calculate. So EG is equal to V plus IA into R. Terminal voltage V is 200 volts, that is given in the problem. Next IA into RA. So IA is we calculate as 34 into RA, armature resistance given in the problem, that is 0.2 ohms. So that we multiply, then we got the generated EMF. EG is equal to 206.8 and armature current IA is equal to 34 amperes. So this is the answer for this particular problem shown in the figure, that is in the problem. Thank you.